the last day of material that's covered on the exam. Okay, so when we come in on Thursday, we'll be doing a review and we'll go back over things. I just put a review sheet out there, like as in like right before I walked downstairs, because I meant to do it last week but forgot. But you know how the review sheet works anyway. It's just telling you what problems, and I've kind of told you that every time we've come in here anyway. We did aggregate and blending. They came from Chapter 4. Last week we did transportation assignment. That came from Chapter 5. And then today we're doing a binary problem. That comes from Chapter 6. And this one is interesting. This is more interesting. But anyway, those are the 5 potential problems, although you only have 4 of the 5 on the actual exam on Friday. Okay. So a binary problem, you know, we kind of give it this name because it's using binary variables in it. It's using binary variables of zeros or ones, and those zeros and ones are triggering something. You know, it's a something happens or doesn't happen. You do this or you don't do this. You know, there's something about it that this binary variable is going to trigger, this all or nothing kind of thing. Okay, so we'll get to see that in action, but we'll first do a quick example that will show us how to put together some binary constraints so that when we get to the end of the big problem, which we'll do right after this one, when we get to the end of the big problem, we'll already be familiar with that and we'll be able to put those binary constraints in. Okay, but we're going to first start with this one that allows us to just kind of learn a little bit about the whole putting binary constraints on. We're going to a football game. We have friends that could go with us, and a lot of them want to go, but we don't have that big a car, so we have to decide who gets to go, and as any good business student, we're going to decide by maximizing our gas money. So that's going to be our goal, is to get the maximum amount of gas money. We have a car that holds 5 people, and that means we can only take 4 other people if there's 6 people that want to go. But then we have quirky friends, so Tim and Joe hate each other, so they both can't go. Sarah and Tom are dating. One won't go without the other. Either they both go or they both don't go. Fred's really quirky. He'll only go if both Joe and Tina go. And then this is how much money they have offered to give us. Okay. So we're going to solve this. We're going to be learning the binary constraints. We're going to solve this, and we're going to figure out that Fred isn't in the solution set of people that are going when Fred's the one that offered us the very most money. So we'll ask the question and run a solver table for it. You know, how much money would Fred actually have to give us in order for us to choose Fred? So we'll do this first, and this teaches us the binary constraints. But then we will do a real binary problem, one where the binary is an integral part of the model actually working, okay, actually being able to work. And that it comes from Chapter 6, it's problem number 93. And you'll see it when we get to it after we're done with it. We'll modify it, and then we'll add a couple of binary constraints similar to what we're learning in the first problem. Okay. So here's the first problem. So here's how we have it set up. There's our 6 friends that would like to go. There's how much money they have offered to give us. Okay. What we're going to ask Excel to do is fill in this range right here with zeros or ones. They can go, they can't go. They can't, you know, that's how we're going to get Excel to do this. So these will be zeros or ones associated with either they are going or they are not going. Okay. We'll put those constraints in with all the things I just said a minute ago, and then our objective will be to maximize the gas money. Okay. So that's this little tiny setup here. So first of all, we know that we're going because it's our car we're driving. So the maximum number of, let me do this real quick. The maximum number of people, of course, at this point that we could hold would be 4 other people. So we got to do something to constrain it in such a way that we make sure that we don't, not we, but that Excel doesn't, you know, select more than 4 people. And we've got to make sure that only 4 are in this solution set of who can go. So what would we do in D9? What could we do? Some of these zeros and ones, and these zeros and ones can't have more than 4 ones, okay? There can't be more than 4 people that get selected to go. Okay. So we would just sum up D7 to I7. We would make sure that that's less than or equal to 4, because that takes care of the first constraint of how many people can actually go with us. Then we've got the whole Tim and Joe hate each other thing. Okay, so we've got Tim, we've got Joe. Okay, so they hate each other, but let's look at all the possible things I guess, that could actually occur. Well, we'll see which ones could and couldn't under the circumstances. Okay. It's okay if neither of them go. It's okay if just Tim goes. It's okay if just Joe goes. It's not okay for both of them to go. This would be a miserable trip. Okay, so we're not going to take them. So we need to figure out something that we could do either mathematically or just comparing cells or just something that we could do to allow these three things to happen and prevent this one from happening. What could we do?
Tim and Joe make it less than or equal to 1.
Yeah, and I would always start, you know, if I didn't jump to that too quickly, I would start by asking, you know, is there some comparison operator I could put in that would make these three work and not this one? But then that would never happen in this case, because a comparison operator here and here, is that's never going to happen, that both of those would work, right? So then you kind of go to the next step, which would be to say, what if I added these things up? Okay. Well, what do I want? I want to allow these. I want to prevent that. Okay. And so if I made this less than or equal to 1, it allows these, prevents that. Okay. So there you've accomplished just exactly what you're trying to do. Okay. So I'm going to put it here. The reference to the binary cell, what's it, Tim and Joe? Tim, that's F7. Add it to the binary cell reference for Joe, that's G7. So add F7 and G7 and make sure that that is less than or equal to 1. So F7 plus G7, make sure that's less than or equal to 1. And that takes care of that problem. Okay, now our next problem. Okay, who are our next problem friends? Sarah and Tom. Okay. Sarah and Tom are dating. A little clingy, won't go places without each other. Okay. So they either both don't go or they both go. This is not okay for either one of them to go by themselves. Okay. What can we do? Okay, wait a minute. Which one did you say?
Not equal 1.
Oh,
Is that an operator we can use to solve it?
Yeah. Okay. So no, it's not. But even yeah, I see what you're saying. Add them up and say not equal to 1. So yeah, no, not equal. That would work if we had that, but we don't. We don't even have a greater than or a less than. We only have greater than or equal to and less than or equal to, which is kind of interesting because on that other one we could have said something like less than 2, but we can't because we can't say that. Yeah, yeah, that would work if we had one of those, but we don't have one of those. So there's something simpler. There's something simpler than that. What did I say? We would start with first. Equal. Equal. Those don't equal. Okay. So if I can just do a logical operator and I don't have to think about summing it and comparing it to something, I take your mind there first because it either will work really quickly or it won't. Okay. And then if it doesn't, then you shift your mind to, okay, well now I might need to add them and compare them to a constant or something like that. But this one works perfectly fine without doing anything other than just saying compare binary variable for Sarah and Tom, doesn't matter which one you put in first, but the E7 equal to reference to D7. It didn't really matter which one you put in first, but D7 and E7 equal to each other. Which one comes first? The next one's a lot more fun because it's got 3 variables, so it starts to get a little bit more complicated. Fred is a complicated friend. So Fred will only go if both Joe and Tina. All right. So there's a possibility that Fred doesn't go, and you'd have all these combinations of what Fred and Tina do. But then, here's all the combinations. So Fred does go. Okay. It doesn't say, I mean, if Fred doesn't go, we're fine, okay? Anybody can go, any combination of people you can go, it doesn't matter. But if Fred does go, okay, it will only be in the case that both of the other two go. It's not gonna go with neither of them, it's not gonna go with just one of them. Okay. So now you've got the allowable and the not allowable choices here. And it starts to get more interesting. So, what was that, Joe and Tina? Okay, so let's say we do that for a minute, because that's not a bad start. But when you do that, 0, 1, 1, 2, 0, 1, 1, 2. Okay, so that is exactly like that. So anything you do to prevent these three would prevent those three. I mean, not anything. I mean, but you have to just think, if you just compared that to a constant, okay? You just compare, there's not a good, but this is okay. This is okay. And to be honest, this is actually going to be the right side of the inequality. Okay. What could we do on the left side of the inequality? No, because we aren't going to do any if statements. One, I don't think the model would solve it all, but it would make it nonlinear. So we're going to do all of this with mathematical formulas and comparison operators, because the if statements make it a whole different kind of model. Yeah. Okay, there's not just one sign. Obviously, you only had 3 to choose from. You know, equal, less than, greater than. You could look at them real quickly, and you would realize there's not just a sign that's going to work here without you doing something over here. Right? You're going to have to do something over there.
Sum product?
No, just a quick and easy arithmetic kind of thing. Nothing that involves, yeah. I'm not sure what you would do the sum product on, but we're just trying to get something that you could do to convert that side of the inequality and compare it to, I actually told you this actually will be the other side of the inequality. Okay, the very first time I did it, I thought, oh, I could add 1 to Fred. I could do Fred plus 1. And then Fred plus 1 here would be 2, and then it's less than or equal to 2. But it'd be 2, 2, 2, which would prevent those 3. Awesome. Fred plus 1 here would be 1, 1, 1. That'd be good, that'd be good, that'd be good. But the problem came this one right here. Didn't work. I added Fred plus 1, I've got a 1, and that's a 0, and now the system broke down. Okay. But there's another way for me to turn that into a 2.
Fred times the sum.
Fred times 2. So we even multiply that. These are all still 0. These are now 2, 2, 2, 2. And when you say this has to be less than or equal to, you know, all the way down, less than or equal to, well, the zeros are less than or equal to all of these. The 2's less than or equal to this one, not those 3. Takes a little thinking, takes a little thought about what you want to do, but I will tell you right now, the day of the test, you won't see one with 3 variables on it, because to have 3 variables on it, it's a longer process to come up with this. It just is. You have to think through a lot of stuff. It gets complicated. Anything with 2 variables, you can do quickly. Okay. But this one, on the left side of the inequality, then I'm going to take the binary variable for Fred, which is an I7, multiply it by 2, and make sure that that's less than or equal to adding up the ones for Joe and Tina, the G7 plus the H7. So over here, I had I7 times 2, and I make sure that that's less than or equal to G7 plus H7. And these take some time. These take some time. I mean, I kind of was leading you through it a little, you know, but they take a little bit of time. So you would only have ones with 2 variables, and they will always be doable. I'll show you that as we get through it. So I've got all of my car and quirky friend constraints listed, and now I need to put a formula in here to maximize gas money. And that would be what? How would I maximize gas money? Yeah, I just want to say it's some product of
Gas money times
yeah, the gas money, and then the range, which will be the binary range of saying whether or not they're going. Because what's happening here is these are zeros and ones. Okay, so you're really only adding in gas money when there's a 1 there, because when there's a 0 there, that'd be zeroed out. So that's giving you the gas money. That will be our objective to maximize. Okay, we're ready to run solver. Yeah, I think I own. It's like a little loud. I think I've only said it, 10 times. No, I don't know. Our objective is to maximize gas money. So D14, maximizing D14, that is the objective. So maximize D14 by changing, yeah, D7 to I7. D7 to I7. Those are those Excel's assignment of you're going or you're not going. And then I always do this first so that I don't forget, is that the very first constraint I'm going to put in, for me, you don't have, there's no particular order you have to put things in, but for me, for my memory, okay, I'm going to just remember to say those are binary variables right there, okay? So I am going to tell Excel right off the bat, because that's what the problem is. Those are zeros and ones that have to be placed in there. So right off the bat, I'm going to tell them that D7 to I7 has to be binary. Yeah. Then I'll go ahead and do the obvious visible ones on the sheet, like my car only holds 5 people and all that stuff. So now, whoops, I could have just said add. Then I start adding, yeah.
Does binary mean there are only 1s and 0s, or there are only 2 answers? Like, can it be one or the other?
They're only 1 and 0.
Okay.
Yeah. And so then I'll start adding the 4 constraints we just spent the time putting in there to say the sum of all the people that are assigned to go to ride with me has to be less than or equal to 4. So it's D9 less than or equal to F9. And then I had the next constraint, which was the Tim and Joe hate each other one, where I added up Tim and Joe in here. But anyway, what I have in D10 less than or equal to what I have in F10, which is adding the 2 of them, making it less than 1. Then I add another constraint for Sarah and Tom, where it's just a reference to each of their cells being equal. So what I have in D11 equal to what I have in F11. And it didn't matter which one you put in which cell, but because they just have to be equal to each other. And last but not least, the one that was much more complicated, that we took a little bit of time on, but what I have in cell D12 less than or equal to what I have in cell F12. That, which what I had in there is spread times 2 and then summing the other 2 on the other side. So I have in total 5 constraints, the binary constraint, and then the 4 constraints that you see right here. And when I go to solve this, I see that I'm going to get $13 out of this, and then I'm taking Tom, Sarah, Tim, and Tina, which is interesting because, again, Fred offered us the most money. How does Fred not end up in this solution? Well, the way Fred doesn't end up in this solution is that if you took Fred, you'd have to have both Joe and Tina, okay? So now you'd have $12, right? Okay, so now you could throw another person in there, right? Well, the problem is you can't put Tim because he hates Joe, and you can't put one of the 2 of them. So now you're just stuck with $12 if you include Fred. Fred's really desperate, though, so Fred is offering more money. Really, really wants to go to this game. So Fred's going to give you extra money, and so you've got to run a solver table to figure out how much Fred needs to give you in order for you to include Fred in the solution set. All right. If I'm going to run a solver table to figure out how much Fred needs to give me, my input or changing variable is what? The money coming from Fred, okay? So Fred's gas money, that's my input changing variable. And what's my output cell that tells me the answer to the question, whether he's going or not?
The 0 and
Yeah, Fred's binary 0, 1 variable, because when it's 0 he's not going, with 1 he is, okay? So that will actually answer the question. It's not the gas money that answers the question. The gas money might be interesting, okay, but it's not the one that answers the question. So when I go to do solver table, the one, it's a one way because the one and only thing that I'm varying is Fred's gas money. That's an I5. So Fred's gas money, that's an I5. And what's a good minimum value? 9. We know we don't take them at 9. And what's a good maximum value?
you do 13.
You do. I would do 13. Yeah. I think I may have done something different on finished files because I just threw a number in there. But a logical one, I mean, you can kind of go with 13. I mean, if you're not, I know we've already looked at the numbers, but, you know, at least at minimum, if you were looking at that, you'd say, oh, at least go with 13. I'm not going to put quarters and dimes and nickels, and we're just going to do dollars. So from 9 to 13 in steps of 1. And the output cell that answers the question is the binary variable cell for Fred, which is I7. Do I maybe want to hold the control key and also see the money? Sure, that's interesting. That's interesting to see how much money. But the one that has to be there is the I7 to answer the question. Okay. So we are varying I5, that's Fred's gas money, from 9 to 13 in steps of 1. And I have to look at I7, but I'm also going to look at D14 just to see. And no, I didn't name the cells this time. Hard to believe, but true. Okay. According to the solver table, Fred would have to give us how much money before we'll take Fred? 11. He's not going to offer more. He's going to do the minimum he has to give us. So he's got to offer us at least $11. Now, it's kind of funny because we're not taking him when he offers, when I say we're not taking him, the solver solution is not including Fred when he offers us $10, which is sticking with the original 13. Although we know, because we looked at it a minute ago, that if Fred was offering 10 and Tina and Joe went, we'd get 13 also. So it does, you know, does it really matter which solution that we went with? We'd have more leg room if we went this one, because then it'd only be 3 people. But that wasn't in the problem. Leg room wasn't in the problem. So, you know, it solved that way. That can happen, okay? That can happen. You answer your questions according to what you see in the solver table, in the solver table output. You answer it according to that. Do we know that it wouldn't have made any difference? You know, there are a couple of different solutions. If he'd offered us $10 that would have come out the same. It doesn't push us over to extra money until he offers us $11. So. Okay, that's not really a binary problem. That's just a little teeny tiny setup in order to learn some of this, how do these binary constraints work. The problem we really need to see is this one that comes from chapter 6, problem number 93. 93. Problem number 93 from chapter 6 that has a lot to it, and I'm sorry I'm going to have to shrink this down for a minute because I want to give you the overall picture of what's going on first. Okay. So here's the big picture. We order products from suppliers. We ordered 8 different products. We have 5 different potential suppliers who can provide us with these. There's a list price for the products, and there is a discount that these people have offered us. Varying discounts from all the suppliers and with regard to all the products. You know, they didn't offer just like an across-the-board one number. It's different. From every supplier, for every product, different discount. They're all right there. Okay. We're eventually going to have to calculate some costs, but we'll get there because we have to have costs. we are going to be getting Excel to tell us how many of any given product to get from any given supplier we'll get to it in a minute, but in order to minimize costs, okay? So how much of any product to get to any supplier. Of course, we want to make sure we get all the products that we need. We have some amount we need. And there's going to be a little thing over here. The ultimate goal of this is to minimize our overall costs. Of course, there's the cost associated with purchasing the products, okay? We've got to purchase them. We're trying to get the best costs, and we're going to try to do that. But there's this other thing. If we choose to use a supplier, then we have this administrative setup fee of $5,000 that we have to pay to get everything set up with that supplier. We don't pay that if we don't use them, but we do pay it if we do use them. So there's that cost also that'll be in here. This administrative cost, and then this total cost, which you can barely see is gray there. Let's make it darker gray. There's this total cost that will be our objective to minimize, okay? The other thing we're getting Excel to tell us, besides how many products from the different suppliers, the other thing we're getting Excel to tell us is whether or not we're using that supplier, okay? Are we using them or not using them? So in other words, this is the binary range. These are the zeros and ones. Do we use them? Do we not use them? Okay? There's one more rule that our company has, and our company has a rule that says you can't get more than 80% of a product from a single supplier. We don't want to be so tied to them that they're supplying us with 100% in case we needed to make changes for any reason. So you can't, the max you can get from any supplier would be 80% of what you need. So that's another rule that we'll have to factor into all of this. Okay, we'll start walking through it step by step. One thing that we have to have are the actual costs. Okay, here's the list price, here's the discount. But if somebody said to you, how much is product 5 from supplier 5, you would be like, you know, haven't figured that out yet. I have to figure that out because I have to know that because that's how I figure out the overall purchase cost. So I've got to fill in this grid to figure out what the actual costs are. So, for instance, what is the actual cost of product 1 from supplier 1? Subtracting, yeah, because the discount is 7%. It depends on how you want to put it in there, but okay, it's 7% less than $87. Okay, however you want to put that in as a calculation, you know, there's a couple ways to do that, but I'll just go ahead and put the list price and then subtract from it the list price times 7%. So take 7% of the list price off of the list price. That's one way. The other way is take list price times
93%.
Times 1 minus the discount. And either way you want to put it in, it's perfectly okay. Those are two perfectly normal ways to put in percent increase, decrease formulas. Okay. You know I'm going to want to copy this. What do I need to do as far as absolute referencing to this one?
Make the column absolute.
Make the column absolute for sure with this B8. Both times it's in there, okay? But what about the E8?
No.
Somebody said it.
Nothing.
Nothing. I mean, it corresponds exactly to every spot in this table. So there's nothing about this that needs, you know, we need to keep this from moving that way, only allow it to go down but not over, but nothing to the EA. The EA is fine. And if you know, you always go back and check stuff. You might be thinking wrong at that moment when you do it, so just move over to a different column, different row, and click on it and see. You know, does it line up with where you are? You know, does everything work okay? All right, so that's kind of an intermediary step. Had they just given us those costs in the beginning and it was in blue, that would have saved us a little time. But they didn't. They gave us the list price and they gave us the discount. So we had to calculate it ourselves. But no doubt we have to have this. Okay, this is necessary for us to have that actual information calculated somewhere. Okay, so while we're on a roll with doing those kinds of things, this is the grid right here that we're going to use to constrain these values. We're going to make sure that we're going to calculate here what would be the maximum we could get of any given product from any given supplier. Okay? And the rule was 80% of what you need is all you can get from the supplier. So in other words, what would be the most product one I could get from supplier one?
That 80% of the required.
Yeah, the 80% of 592. Okay, so I need 592. The most I can get is 80% of that. Okay, that's the most I can get. It's our company policy. So what do I do to the I-22?
You want the column.
Do we want to round it down?
It's not going to be necessary because we're going to do an integer constraint over
Okay.
these. And so, yeah.
Absolute B4.
Completely absolute reference on the B4. So I'll go ahead and just press my little thing there. What about the I-22? Column only. Okay, so it ends up being $sign I-22 times $B, $4. Okay, the reference to I-22, it's just the column that's absolute. The reference to B4, it's everything that's absolute. Of course, we're going to check that. Okay, so after we go to copy this, I'll just move to another row and another column. Well, I can't see it because I moved. Okay, and then I see that it's obviously using this required total here and the 80%. So everything is good. You spot check things. And it shouldn't seem weird to you at all that that's the exact same number going all the way across there, because every supplier is constrained by 80%. So 80% is 80%, okay? But why did we write it out like this? You know, why don't we just put it in a column and say, well, that's the max you could get, okay? Well, the reason is because it will make it easier when we set up Solver, when we say that this, every value in every one of these spots has to be less than or equal to every value in every one of these spots. So it just made this setup easier when we put this constraint. We're going to use this to constrain this. And so it being in a grid is more helpful to us. Okay. I know it's the same number all the way across the row, but it's just more helpful to us. And a really good question about, you know, because you're going to get these decimal place, you see them now that you have these decimal place values. That isn't going to matter for us because we will later make this integer, and that'll make it where it's not an issue. Okay, some of the may seem easier stuff. Well, this one for sure. We have to make